Today we will be focusing on Fischer esterification. So what are esters used for? They have characteristic smells and are responsible for flavors and smells. They can be used for flavorings and perfumes. An example is 3-methyl-butyl ethanoate, which is the scent for bananas. Esters are formed using alcohols and carboxylic acids in a process called esterification, which is a reversible reaction and so requires an equilibrium arrow. To do this, we need a nucleophile to attack the delta-positive carbon, and this requires a catalyst because the hydroxyl is too weak and the carbonyl is not electron deficient enough. The most common catalyst is sulfuric acid. This is because it is a strong proton donor and a dehydrating agent, which is helpful in sequestering some of the water produced in the reaction. The process of esterification is done in 4 steps. Step 1, protonation. Step 2, attack of the nucleophile. Step 3, intramolecular proton transfer. Step 4, elimination reaction, whereby the catalyst is reformed. In step 1, the carboxylic acid takes the proton from the sulfuric acid. The proton attaches to the oxygen with the lone pair, which is double bonded to the carbon. The carbon is now more electrophilic. Now in step 2, because the carbon is now electrophilic, a nucleophile can now attack it. Lone pairs in the oxygen of the alcohol attack the carbon, which then pushes the electrons from the double bonded carbon onto the oxygen. This forms a tetrahedral intermediate with a delta positive charge on the alcohol's oxygen. As the oxygen is now an acidic site, it wants to give away its hydrogen. This results in an intramolecular proton transfer. The OH that is bonded to the central carbon then gains a hydrogen, forming water. As the OH is now protonated, OH2+ is formed, also known as H2O, which is a very stable leaving group. In this step, the acid is reformed by displacing water. The sulfonate anion formed back in step 1 takes back its hydrogen to reform itself, and the electrons from the broken OH bond reform the double carbon-oxygen bond. Water then leaves, resulting in an ester and water. Let's put all 4 steps together for the mechanism for the reaction of 3,5-dinitrobenzoic acid with methanol using sulfuric acid. Step 1, protonation. Carboxylic acid takes a proton from the catalyst, forming an electrophilic carbon. Step 2, attack the nucleophile. Alcohol attacks the electrophilic carbon to form a tetrahedral intermediate. Step 3, intramolecular proton transfer. Alcohol loses hydrogen and water is formed. Step 4, elimination reaction. Catalyst and double bond reformed. Water leaves and an ester is formed.